In our second example with cosecant, we're going to take a look at how we would graph if they just presented the function itself without the reciprocal function right next to that. So here we're asked to graph y equals negative cosecant of pi x. So I'm going to first rewrite it as this. We want to think of this function as y equals 1 over negative 2 sine of pi x. So with the reciprocal function, we're going to take a look at how the parent function is changed for sine with the negative 2 and with the pi. So the amplitude of sine is the absolute value of negative 2, which is just 2. The period is typically for sine 2 pi, but we're going to go ahead and divide it by pi, which is the constant out front of x. And that means my period is just a regular 2. And then finally, what does the negative do in front of the 2? It flips the sine function. So instead of my function looking like a hill and a valley, it changes it. So the negative 2, what we're going to see is that my valley comes first before my hill for each cycle. So let's go ahead and put in our x-axis here. And let's say that we were asked to graph 2 cycles of this. So we're going to go ahead and put in points for our sine function. So one cycle is 2. The next cycle would then be completed at 4. Within the first cycle, we're going to divide it into quarters. So we have, if I divide it in half, that's 1. So this is 1/2, 1, and then 1.5, or 3 halves. 4 halves, 5 halves here, 6 halves is 3, 7 halves, and then 8 halves is 4. So we're going to also put on our y-axis, our amplitude is going to be, our highs and lows are going to be achieved at negative 2 and 2, where instead of a hill then a valley, as a typical sine function would go, because of the negative 2 out front, we're going to do valley then hill. So start off at the origin for all sine functions. Then the low is going to be at negative 2. Back to the x-intercept, 2 is going to be the high. Back to the x-intercept, low, x-intercept, high, then back to the x-intercept. We're going to switch colors now. And we're going to graph its reciprocal, y equals negative 2 cosecant of pi x, by putting vertical asymptotes through all of my x-intercepts. And then from there, your concave up, concave down from the 1s and negative 1s. So we get our final graph has 2 period. By the way, a period for cosecant and secant would contain one of the branches of concave up and then the other branch of concave down. So to highlight that for you, this would be considered 1 period, and then the other period would be the next cycle of 2.